If there are any questions or comments, feel free to interrupt at any time. I don't mind. I really don't mind. The old-fashioned attendance register. Let's have a preview of the exciting topic today. This is a preview. Last time we talked about streamline integration, so how to compute a single streamline from the seed point to the end, the terminal point. Today we're going to continue on that theme. The challenge with streamlines is you have to put them somewhere. You have to seed them somewhere. You know, you need a strategy. And there are different consequences for different strategies. And that's what we're going to talk about today. This is a streamlined seeding algorithm that we're looking at right now. So it shows it shows roughly evenly spaced streamlines on surfaces. These are all streamlines, and they're showing the characteristics of the flow just underneath the surface of that object. And there are different streamline seeding strategies. You can choose seed points randomly, but it's not very nice if you just choose them randomly. You can also try to choose them on a grid, but that's also not very nice, as we'll see. And then you can try to get some distribution that is maybe somehow more sensible. Because if you choose random streamlines or a grid-based seeding strategy, the resulting streamlines are not distributed very well across space and across flow features. But these, you can see, are distributed across the surfaces in a nice way that captures all the characteristics of the flow. So that is one of the topics we study. Gesundheit. This video was made by a Swansea University student, a very talented Swansea University student, by the way. So, well, he's no longer a student, but he used to be. And he was good at it. And it's a really nice video. And of course, you can see it on the module YouTube channel. And right now, you're looking at it wondering what's going on. We're going to show it again at the end of the lecture, and then you'll have a different understanding of what you're seeing. So this is just a preview. Okay. So last time we talked about glyphs and numerical integration. That's a fun topic, the numerical integration one. I think everybody on Monday evening that was there, anybody remember that lecture? For the people that weren't there was a standing ovation at the end. And that is a difficult topic, and it is a common test question. And so there is a special tutorial on the DataViz YouTube channel where I take out a marker and a whiteboard, and I do it by hand, step by step, very, very slowly, for anybody that wants to have a more in-depth understanding of how that works. Okay, so now we're going to talk about flow visualization with streamlines. Anybody remember what a streamline is? Look. He's sitting right in the front.
Yeah. It's like an estimated path based on all of the vector ones.
Estimated path of what? You're correct. but it's almost, it's not quite complete. Path of travel, yep, that's getting closer. What's traveling?
I think the example of the control. So objective with what direction it will follow.
That's correct. That's correct. It's the path of a massless object would take. In some literature, it's called a fluid parcel. It's an imaginary object because there's no such thing as well, at least not for purposes of this class. There's no such thing as a massless object. So it's the path a massless particle would take. There's another way to define streamlines. Anybody know there's a kind of more mathematical way? Anybody remember a more mathematical way? It's a curve everywhere tangent to the flow. And tangent means aligned with the flow or the vector field. Okay. So that's what we're talking about. And we need a strategy to seed them or cover the space. So here's some streamlines, and they provide a nice overview of the flow. These do not show downstream or upstream direction. They show orientation only. These show downstream direction, so you actually know that the flow is moving that way. So higher opacity indicates the direction of the downstream. And here are some more 3D streamlines. Streamlines are curves that are everywhere tangent to steady state flow. Steady state flow is time independent flow. The flow is not changing, it's static. It's like taking a photograph of some water, like a river. There are other kinds of curves, not just streamlines. One's called Pathlines, and another's called Streaklines. So a pathline is a curve that's tangent to the flow in the unsteady case. So time-dependent flow. It's also called unsteady flow. And then there are streaklines. Streaklines are analogous to injecting dye, a source of dye or color into the flow, and then watching the curve that dye traces out in the flow. So they're not always tangent to the flow, actually. An analogy is, imagine I'm on a bridge and I'm looking down and I see a river, like River Tawe, a beautiful River Tawe. And I drop a piece of, I drop like a chestnut off the bridge, and it hits the surface of the river, and then I watch it float away. The path that chestnut takes would be very, very much approximating a path line, because it's unsteady flow, right? It would start to move, and then the river is also changing over time. And then if you could imagine the trail that the single chestnut leaves as it's floating down the river, if you can imagine the trail that it creates or that it follows, that's a path line. If you were to freeze the river and drop the same chestnut and then have it like move, then that would be a streamline. So one's steady state and one's unsteady state. Does everybody follow me so far? Have I lost anybody yet? This is where it gets a little bit tricky. The streakline case. So streamlines, the path lines are the curves that only one massless object takes through the flow. one massless object. Drop it at a certain position and watch it go. A streak line is, imagine we're looking over the bridge again, and we have paint, like blue or green paint, environmentally friendly, biodegradable paint, massless as well. And then we are able to squeeze it very slowly, so it's just dripping, like dripping at like 2 hertz, 2 drops a second, or it doesn't matter, 5 drops a second, 10 drops a second. And we're looking down, and we're watching it as it hits the water. Right? A drop would hit the water, it would move with the flow, and then the next drop would hit the same spot and then move with the flow again. Now imagine joining all of those pieces or drops with a curve. Imagine joining them together with a curve or a line. That's a streak line. It's not the same as a path line. The path line was the curve traced by a single drop moving down the river. The streak line is a continuous series of drops or particles dropped into the flow at the same spot over different times. Did that make sense? Hopefully. It's a little bit confusing, but the streak line is actually kind of, in some ways, the most intuitive, because that's what fluid engineers actually do. They have flow in a tank, and they squeeze color in there and watch it go, watch the curves. So here are some streamlines that are color mapped. So red means high velocity and blue means relatively slow velocity. And these have been placed manually, right? They're not everywhere distributed. They're placed selectively, right? There's the vortex shedding again. Everybody remembers that, I'm sure. These are streamlines with special lighting and shading. They're treated as if they were emitting light. So they're called illuminated streamlines, and they help the perception of depth in 3 dimensions.
Mm-hmm.